Hello everyone, this is Gary Marr from Glendale Community College. This screen capture is for my CIS 150 AB online students. And in this screen capture, I'm going to talk about topics, terms, and concepts covered in Section 3 of our textbook. Section 3 is going to cover structured programming or programming structures. In Section 2, I talked about identifiers being the nuts, the bolts, the screw, the glue that was going to be used to kind of hold our logic together. Well, in this chapter, we're going to talk about those statements or those conventions used to actually implement the logic. This is where the rubber meets the road. This is where we put the brains, the intelligence, the decision-making inside our logic to give us a solution to some problem. Now, almost all computer programs are based on inputs that are processed into outputs. The inputs are typically brought in from files or keyed into the keyboard. The processing is typically logic, which will take that input in the form of identifiers, massage it, control it, move it, exercise it, assign it to create the desired outputs to solve that business problem. So we're in the middle piece now. We're in the processing piece, and we're talking about decision structures. There are 3 decision structures we're going to cover in this class. One is a sequence structure, which essentially is an expression, a calculation or assignment, something we talked about in Section 2. A decision structure, which is for all intents and purposes is an if statement, as shown on this screen. And then finally, a repetition structure, which actually could be 3 different things. It could be, it's all looping, but, a repetition structure. It's all looping, but it could be either a while loop, a do until loop, or a for loop. So that's what we want to talk about in this section of the course. So, starting with sequence structures. Sequence structures are the simplest structure. They're essentially an expression, a calculation, an assignment. They're represented in a flowchart as a square, which we can see here. And in pseudocode, they typically are just going to show up as some sort of calculation or assignment, typically something on the left side of the equals that's going to perform addition, subtraction, whatever assignments, and the left side would be where that outcome would be stored. It's the simplest of the 3. And in Visio and also the other flowcharting tools, you're going to use the process symbol, or it sometimes goes with different names, but it's a square box. And inside that box, along with the other symbols, you're always going to have text that describes what's actually taking place. Now, the capsules, this is a little bit of review. The capsules at the top and bottom will always be in your flowchart. They'll also always be in pseudocode, although I did not put start and end here in my pseudocode. And then in each one of the symbols, there's going to be some text that explains what's going to happen. Hopefully what you're starting to see here is the text that's in the pseudocode is pretty much the same that shows up in the symbol. Now, with flowcharts, we only have assignments 2 and 3. They're going to use flowcharts. And then from then on, we're just going to stick with pseudocode because flowcharts start to get a little bit dicey here in terms of the complexity and the time it takes to put them together. It's also difficult to show complex problems with flowcharts just because it takes a number of pages to get all these symbols and everything lined up with arrows going in the right direction, not crossing, etc. So, for at least the first couple of assignments, the second and third, we're going to give you guys some exposure to flowcharts because a good chance you'll see it in some of the other classes or on the job. Decision structures are a new structure. This is your if statements. And with if statements, you typically have branches. One branch is true, one branch is false. What branch is taken depends on the Boolean expression or what's being evaluated. To look at this flowchart, the Boolean expression is the diamond. Okay? In there would be a logic statement, much like we have in the pseudocode. Here's a pseudocode, here's the flowchart. So if books are greater than 3, this is missing a parentheses here. Then if that's true, you're going to do this branch, and if it's false, you're going to do this branch. Now, if statements only have to have the true branch. They don't have to have an else. That's optional. This one has both. From a flowchart standpoint, the Boolean expression, which is what it uses to make the decision, is a diamond. And then I have 2 sequence structures, which are reflected here also in the pseudocode, that perform a calculation. The lines come together at the bottom of these 2 branches and move on to the next symbol, which in this case happens to be end. Okay. If it was a single branch if statement, the false would not appear. Now, what you have to make sure you do with your flowcharts is you always have the arrows. The arrow head is always pointing the correct direction. You have for the diamond a true and a false, or at least a true, optionally a false. But if you do have a false, they both have to be labeled. They have to go into one symbol and one symbol only. And if there's multiple symbols here, multiple sequence structures, then fine, just show them one right after the other. They have to come together at the end and then show one arrow coming out. This would be for a structured golden flowchart. Flowcharts aren't used a lot anymore, but they still are used, especially if you're going to sit down with a user and try to explain a process to them. Because since these symbols are structured and they mean the same things, Boolean expression, sequence structure, they can sometimes understand this a little easier than they can with code, like with pseudocode, which tends to be a little threatening. And with pseudocode, there is no standard. I mean, anything goes. Just like if you're giving directions to someone to get to the mall, your directions might be different than someone else's. They both might work. That's what pseudocode's like. Computers don't like that. Computers have to have a very structured sequence of text statements, and we'll get to that when we work with Python. You're going to find that I'm going to show you examples in Python to go with the pseudocode, because pseudocode can't be executed. It can only be looked at, and we can certainly get an idea of what the model should look like. But if we really want to test it out to make sure it works correctly, we need to put it in a programming language. Python is the easiest one for us to do that with, and that's why we use it in this class. You will not be tested on Python, but you can use Python in your answers for both assignments or also for test questions, if you, in fact, want to prove that you're giving me the right answer. Repetition structures are loops, and there's a couple kinds of loops. There's while loops, there's do until loops, and there's for loops. And we'll talk about each one a little bit later in this presentation. And all a loop does is it repeats a series of statements or a sequence, of symbols or statements. I guess either one would work here, until the Boolean expression is false. So it again has a diamond. So in this case, it comes down and determines if count is less than 11. If it is less than 11, it takes the true branch, executes these two statements, comes around again to see if the value of count has changed. Now, typically, when we do our programming, the count value would change, and it would probably increment some number of times. If it fails to increment, that's called an endless loop, and we will talk about that at some point also. But this is what's called a pretest loop, which means that if the count value is greater than 11, it'll never execute this branch, or never ever execute these statements. That's different than a post-test loop, which the testing is done at the end of the loop. So it always executes the body of the loop at least once. And we'll get into this some more. All of this stuff will be repeated over and over again each week we cover the material in the class. The identifiers and the programming structures are fundamental to everything we do with procedural programming, with object-oriented programming. Every programming language has them either identical to what we're covering now or very, very close. So if you're not sure if you understand it yet, just stick with it, and it'll get better as time goes on. Logical operators are a little different than arithmetic operators, in that they essentially are used in Boolean expressions to help determine whether the expression is true or false. You have an equity operator, which I've got here is double equals. I believe the only programming language you guys might run into that would have an equity operator of a single equals would be Visual Basic. But an equals in an assignment is different than an equals when it's comparing whether two values are the same. So when we do a comparison for true or false, we use a double equals sign. Whereas if it's an assignment, we use a single equals sign. You've probably already seen the assignment equals sign in examples we've covered in sections 1, 2, and now 3. The equity one will be new for you. Then we have greater than equal, less than equal to, and then not equal is the exclamation point and equal sign. This can vary by language also, but the most common one is the exclamation point equal sign. Do not get the characters reversed here. On the greater than or equals, the greater signs first, then the equals. It's not an equals, then a greater than. That will give you a syntax error because that's invalid. Compound operators are used when we have multiple Boolean expressions. And I hope we will have some other videos to show you some of these examples. We don't do a lot in this particular one. But this is when you have books are greater than 3 and cost is less than 10. So essentially there's two Boolean expressions that have to be evaluated. If they're both true, well, first of all, if they're joined with an and they're both true, then the entire expression will branch to true. If it's an or, only one side has to be true. Okay, this works for both if statements or decision structures and also repetition structures or while loops. And there's a lot more on this in the textbook, and there'll be examples also in the files folder of Canvas on this. Flowcharting rules. Flowcharts are not a dominant part of what we do in this class, but there are some rules you should try to obey. Do not cross your lines with flowcharts. The lines should not cross. You need to position your symbols and arrows in a way so they don't cross. Each symbol should typically have some text inside of it describing what it does. Every flowchart should start with a terminator symbol with start and end with a terminator symbol called exit. There should be an arrow. The arrowhead should be pointing the correct direction. For most of the symbols, there's only one line coming in. And in the case of a diamond, there's two lines coming out. But almost all the other symbols would have, and there's a lot of symbols, we won't cover all of them, but the ones we're covering will have one line coming in, one line going out, with the exception of the diamond, which could have one line coming in and two lines coming out. Okay. If you have to draw a flowchart across multiple pages, there'll be some examples of this. We won't spend a lot of time of it in lecture, but you'll be able to see them in Canvas. Then you want to have an off-page connector, which essentially is a letter or a number. That's at the bottom of the arrow of your last symbol on your page. And then there'll be another page showing where that symbol comes in and picks up the logic from there. This is one of the problems with flowcharting. It just takes too many pages to diagram logic. It gets to be unwieldy if it's a complicated problem. You can also nest structures. Here is an if statement that has a true branch that does a sequence structure and has another if branch or another if statement with a Boolean expression. Now you can not only nest decision structures, but you can also nest decision structures with loops with decision structures, any combination thereof. Because again, what the structures are going to do is give our program the logic necessary to figure out complicated things, which means decisions and loops and repetition and Boolean expressions. So these can get quite complicated. We talked about the debugger in the last section. Debuggers are very helpful in terms of figuring out exactly if your logic took the path that it was expected to take. If it didn't take the expected path, then it's probably a logic error that has to be fixed. Pretest, post-test. Whether you use a pretest list or post-test loop probably doesn't make any difference. Depending on how you set up counters and sentinel values, and we're going to get some practice with this, you can use a while or you can use a do while, or do until, I'm sorry. This is a pretest loop, this is a post-test loop. The pretest loop may never execute the statements inside the loop. If the country is not USA, it goes around it. Okay? Whereas a post-test loop will always execute the statements at least once, then it'll make a decision as to whether if it's going to come around and loop again. I have some real nice examples that I can use, and I'm not sure if they're in the, I can't remember if they're in the PowerPoint, but you'll see them in Canvas, where I do just a simple collecting of test scores for a class average. And this will walk you through and show you the benefits of looping and repetition. The biggest benefit for me for repetition is that if I didn't have it, think of this scenario. If I had to average 35 students in my class for test scores, I would have to take each student's test score, input it, add it to a running total, and at the end of the division. So that means 35 blocks would have to be repeated with 3 statements 35 times. So my program's now 100 lines long. If I have a loop structure, I can simply say, okay, how many students do I have? 35. Great. Then loop 35 times asking these 2 questions. What's your score? Well, actually, asking one question, what's your score? Now add your score to the total. So instead of my program being, 100 lines long, it's now like 10 lines long. which is a much simpler thing to ensure that the quality is correct, there's not any issues, it's less time consuming, it's a much better way to go. So one of the big benefits of repetition is code reduction, and there's also some things that loops do for us in terms of data validation, which is very handy. One of the first things we'll work on with these structures is making sure that the input that's going to the processing that comes out as output is valid. And when it comes to checking input, a loop is a very nice way to check the input, and if it isn't correct, asking the person to key it again. The option would be, if it wasn't correct, having the program die. That would not be a good thing. Looping allows us to fix problems, come around again, do some more processing. That's one of the benefits aside from code reduction. Expressions we've already talked about. These are simply calculations and assignments. We do a lot of this. In fact, I think for a lot of students, we come in with a misconception computers are smart. They're not terribly smart. They have to be told everything in a very simple fashion. And sometimes what we would even look at intuitively and just understand without even a second thought might turn into 5 or 6 assignment calculation statements with a computer. So these break the problem down into steps that we can then get the computer to process correctly. Operators, arithmetic operators, we've already talked about. Operator precedence, we've already talked about. Here's an example of a pre and a post loop done with flowcharts. And again, the pre-test, before you execute the loop, the true statement, the Boolean expression has to be evaluated, whereas the post-test, these 2 statements are done, then it's evaluated. It's good to kind of look at these in contrast. I don't think there's anything that I require that says you have to use a pre or post test. They both will work depending how the problem is set up. And when I say set up, it usually has to do with counters or the logic that takes you in and out of the loop. There's usually some initialization that must occur with one that doesn't on the other. And with practice, it'll become very intuitive, and you're going to get plenty of practice by the time this class is complete. 2 of the things that we do a lot with loops is counting and accumulating. And there is a difference. Counting is simply just adding by or subtracting by a common number. Up by 1, down by 5, up by 5, whatever. That's a counting process. An accumulation process is where we have a running total, like with the case of a test score. We have an identifier variable called total score that's going to hold the score, and then we're going to continue to add student score to that on each iteration of the loop. So it's going to get larger and larger and larger. The difference being counting is usually going up or down by a set number, whereas accumulation is up or down by a number it's not known in advance. Typically, it's the number that's inputted into our logic processing. Here's an example of a couple different control structures used together. We have an if statement and a while statement, or a decision structure and a repetition structure. And this is very common. These can be very, very deep and very complicated. This is where the advantage of writing logic is. This is why a computer can help us. If we're validating, several different fields for an electronic transaction, and there's several rules that go into place in terms of how it's calculated, all of that is done with control structures. Questions, if you have questions, ask away. There'll be other examples and videos in this module and preceding module that'll show you some examples of how this works, primarily in probably pseudocode and then also with Python, so that we can actually run the program so you can see what's happening. If you have any questions, please let me know.